Wonderful. We have a recording. Thanks for making the time to come hang out with us this evening. I think I know everyone on this call. I think we've got a lot of the new Chico's cohort on here, but anyone who I haven't met, I'm Kate. Hi. Super excited to be kicking off this webinar series today. This is our first technical webinar for 2024, coming off the back of our first non-technical webinar last week about how to be a conference speaker. And if you didn't listen to that one, let me know and we can share the recording. It was a really super interesting conversation with four incredible women in the Perth tech ecosystem that were sharing their experience of how to be a conference speaker and tips to get you started. But tonight, we are joined by the lovely Alisa, who's going to be telling us a little bit about how the internet works. And I'm super fascinated because I've read the dot points and the cliff notes and had been a little fly on the wall for some of this discussion, but I bet that there is a lot in here that I don't know either. So I'm going to be eagerly listening along while Alisa is telling us a little bit about the internet. So I am going to pass over to Alisa. We are recording this session, so if you miss anything, you'll be able to watch the replay a little bit later, or maybe you are watching the replay and you're seeing this for the first time in the future. Hello from the future. So without further ado, I am going to pass over to the wonderful Alisa, and hopefully we all enjoy and have a fun learning experience this evening.
Thank you. Thanks so much for having me here, Kate. I'm excited. I'll just give a little intro. So I'm a software engineer. I work in public transport payment infrastructure. But I think what's important to know is that in a previous incarnation, I was a curator and a producer in the field of computational art. And you might definitely notice in this presentation sort of the places where my attention hovers. Yeah, is influenced through that background in the arts. I just want to give, some context around the history of the web and personal computing, why things are the way they are. And I'm obviously not going to cover every example. This is just one history of the web. There are many histories, and there are also many internets. When we talk about our internet, the internet that we're all on right now, there are historical alternatives that didn't take off. And there are also alternatives that make up small components of the broader internet, and are sort of subsumed into it, don't always operate in the same way. But there's things like sort of Usenet groups, which the internet has taken parts of it, but it's a different internet to the internet we're talking about. Anyway, this is one of my first times doing this, so if there are ways that can be improved, let Kate know. She'll pass it on to me. I'm going to suggest that people put questions in the chat, and I'll keep an eye on it and try and answer them as they come up. And if I don't get to them, we'll just open up at the end. Hopefully there'll be time for just like an open discussion. So I use a lot of metaphors in this talk. Here are ways that the internet is represented as a web, as a world. And the internet, its genesis was at the same time as this, the Whole Earth Catalog. This is 1968, and sort of the birth of the internet was 1969. People think of this Whole Earth Catalog as the cultural predecessor to the internet. So you might have heard of it. Its slogan was access to tools. It was a publication that was sent out. It had a bunch of DIY instructions for making your own tools and homes and things. And it was about the democratization of knowledge, which is kind of what the internet did not too long after. So the birth of the internet, 1989. I've got a short clip from a Werner Herzog documentary, which I'm pretty sure is not working for my embedded. Nope. But let me open it up in another tab. So just something to say about this. If you're familiar with Werner Herzog's documentaries, they're very dramatic. He's got a strong authorial voice. So bear that in mind. What I think is interesting in this clip is you get to see the physical hardware from from the first transmission of the internet. It's kind of huge military style machine. So I'll just play.
This is the campus of the University of California in Los Angeles. Today, no one of the students is aware that this is ground zero of one of the biggest revolutions we as humans are experiencing. One of the science buildings here is considered the birthplace of the internet. This picture of some of the scientists involved was taken at this very moment. The corridors here look repulsive, and yet this one leads to some sort of a shrine reconstructed years later when its importance had sunk in.
Let's enter this very special place. We're now entering a sacred location. It's the location where the internet began. It's a holy place. We've just come back to 1969 when the critical events of the origin began. That machine over there is the first piece of the internet equipment ever installed. It's a mini computer, which we now call a packet switch. This is a military hardened machine. You can't break it. And it was meant to sustain itself unattended for years at a time. This particular machine is so ugly on the inside, it is beautiful. It has a unique odor, a delicious old odor from all the old parts. It consists of modems, CPU, logic units, memory, power supply, all the things you need to make an efficient computer work. This machine served as the first node of the internet for decades. And it was from here that the first message was sent. A revolution began. And the only record we have of what happened that day is in this log. On October 29th, 1969, at 10:30 at night, we entered that we talked to Stanford Research Institute, host to host, computer to computer. It's very much like when on Columbus's ship, the fellow up on top who first spotted land, he noticed it was, and he basically made an entry saying, we spotted land. That document and this document have at least the same equivalent words. And what was that first message? Many people don't know it. All we wanted to do was log in our computer to a computer 400 miles to the north up at Stanford Research Institute. To log in, you have to type LOG. And that machine is smart enough to type the IN. Now, to make sure this was happening properly, we had our programmer and the programmer up north connected by a telephone handset, just to make sure it was going correctly. So Charlie typed the L. He said, you get the L? Bill said, yep, got the L. Type the O. You get the O? Yep, got the O. Type the G, you get the G? Crash. The SRI computer crashed. So the first message ever on the internet was lo, as in lo and behold. We couldn't have asked for more succinct, more powerful, more prophetic message than lo.
Yeah, so as I said, quite dramatic. As a fun story, which is that's Leonard Kleinrock, so he was one of the internet pioneers, but Werner Herzog insisted that he deliver all of his lines directly facing the camera. And then after he'd wrapped up this documentary, he cast him as the villain in a fictional movie he made. So he clearly had a narrative in mind for him. But anyhow, you get the idea. You can think about the first internet as two computers just talking to each other. And if you think about it this way, the modern internet is an extended version of that. So many computers talking to everyone. And a website is just a conversation between a server where the files for that website are hosted and a computer accessing that server. So this talk is on my website at the moment, which is lisa.pizza, which when I was putting this together was hosted by this company, nearlyfreespeech.net, which is a nice hosting company. You pay, rather than paying a big yearly sum, you pay like a gas meter. You put in money depending on the site usage. So I tried to look up where physically my site is hosted, which I thought was here in Florida, but then I emailed them and they said, actually, the servers are in Phoenix and Boston. And I'd asked if they could send a photo, but apparently that's not allowed. So I found some sort of typical data centers. Maybe it looks something like this. Jeff said that it's less glamorous than this, so maybe imagine it with a bit of dirt and grime. But you can see the internet is this physical infrastructure. I also Googled some images for what is the internet, which I thought I'd show you some of those. Yeah, it's got these thousands of ones and zeros being displayed, transferred. These images that look like these abstract formation of modems and laptops and sort of fuzzy clouds. But at a more abstract level, what it's really trying to say is just computers sending messages to each other connected through different places on the internet. And here I thought it was interesting, early pattern drawings of the internet, people still didn't really know how to represent it. You've got sort of these blobby clouds or like a brain or an explosion. But yes, it's just a bunch of computers on a network talking to each other. But the network structure itself is important. So there's this canonical diagram from, I think, the RAND Corporation. And when the internet is being its best self, it's this distributed network on the right. Every computer has the potential to talk to any other computer on the network, versus something more centralized. I've put in some examples of like these three different kinds of networks: centralized, decentralized, and distributed. There's the centralized panopticon. So this is a model of a prison system where the guard is in the center and he's got a view to surveil every prisoner from that vantage point. There's air traffic, which is a decentralized network. So it might look distributed, but actually you can't just go from one small city to another small city. You've got to go through these central hubs. And maybe that's something like what the internet becomes when like big social media networks take over and become locuses of control. And here's a road highway system. So this is more of a distributed network. And you can think if there's traffic in Oklahoma City, then you can easily route around that and go another way. And in that way, every node on the network is connected to every other node. I think it's also very interesting that the internet itself, as well as being physical, is actually built on the network of submarine cables. So these are cables that were laid in the 1800s for telegraph and Morse code. And they go underwater and they were already established. And so the internet was built upon this infrastructure. And these networks, you can see from the map, also reiterate the lines of colonization. They go from the colonial powers to their colonies. There's a cable stretching down to Cable Beach, up in Broome. And so the internet, as well as not being ethereal, as well as being very physical, also reinscribes these lines of power. And there are places, particularly Indigenous communities in Australia, that have limited access to the internet. The internet's not a resource that is particularly democratic in this way. Let me just check the chat. Ah, yes, good. Everyone talking about Werner Herzog. I also love him. Right. Here is a Google cable being laid. It's like I've held one in my hands, big, thick cable, twisted wires. Here is a shark attacking one of Google's cables. It's an internet activist of some kind. And Sputnik. Yes, so the shark connects to Sputnik. Sputnik was the first Earth orbiting satellite. The cultural meaning of Sputnik is that the US realized that they were behind in their space and technology race. So once they saw the Soviet Union launch this satellite, they thought, oh shit, we better get on top of things. That led to them developing ARPA, the Advanced Research Projects Agency, which is now DARPA, with the D standing for defense. And ARPA was the organization that developed the internet, actually, it's got this basis in this military history. And that's common to a lot of aspects of computing. They were developed or designed initially for war. Computing power really took off in the 60s, building on the work of these huge computers used in World War II that solved equations for atomic bombs. So, war is this thing that accelerates technology. I'm going to read out this quote by Alexander Galloway. He says in his book Protocol, "While many have debated the origins of the internet, it's clear that in many ways it was built to withstand nuclear attack. The net was designed as a solution to the vulnerability of the military centralized system of command and control during the late 1950s and beyond. For the argument goes, if there are no central command centers, then there can be no central targets and overall damage is reduced." So, from apps we use like Instagram to facial recognition, the military technology we use is a way for the military to seize control. Every new step forward in technology has some kind of ulterior motive. Here is ARPA, and then they had a rebrand. And this is Lawrence G. Roberts, two photos of the same person who was in charge of ARPANET. And this is ARPANET. So the internet in 1969 was not the internet we use today. It was one, maybe two, probably just one computer at 4 locations talking to each other, just as in the video we watched at the start, one letter at a time, often crashing. So a pretty slow start, and you can see it's only at universities. Another narrative of the internet, aside from this military origins, is one where, so like an alternative is the engineers that actually worked on the internet were not military people. They came from academic backgrounds, and their ideals maybe had more to do with free speech and no censorship. So even though they designed a network that could reach around centralized damage, maybe the damage they were concerned about was censorship more than nuclear attack. This is the network growing over the following decades, which is quite cool. The 1960s to the 1980s, primarily universities having access. And I've switched onto packet switching. So the internet is built on protocols, the most important of which being packet switching. I think this is a neat GIF. We can watch this while I talk about packet switching. So messages that are going from one node of the internet to the other node of the internet are broken into these small units called packets. So packets made up of the header, and that's got information about the address it's going to and processing. And then it's got, aside from the header, the data that makes up the content of the packet. And sometimes that data is just a single byte aside from the header. These are transmitted 1 bit at a time, so you can actually measure the length of a packet in millimeters. I think that's cool. And from the moment you turn on your computer, any network computer, the computer you're using right now, it sends, receives, stores, and discards packets, which you would never know about. You can only read if you install a packet sniffer, and then you need to decode it from hexadecimal. And the path that these packets take, you can see they're all taking different paths. The protocol of IP tells them which is the best next node to move to. But you, the user, will never know the path that it takes. If you try and source route your packets, then the hosts are going to say, this is a security risk, and reject it. So if you want a definition of the internet, I think a pretty good one is the constant sending of necessary, unceasing, and involuntary transmissions, which are opened, broadcast, and redirected by unknowable others. It's this thing that's always happening in the background you cannot see. And developers love this. They love this idea of encapsulation, the fact that you can't see the inner workings of the thing, you just interact with the thing. Probably enough about packet switching. Ray Tomlinson developed email. The start of the internet, the diagram I saw before, all these universities, academics trying to get in touch with each other, developers contacting each other based on messaging, and they all had to have, so they needed a software so they could easily communicate with each other. Ray Tomlinson wrote the first email software. The only photos I could find of him were with the @ symbol, because I guess he came up with it as, Alisa at gmail.com or whatever. But it's an important protocol, one that maybe we don't even notice anymore. It's so familiar. Here's another .com, .net, .org. These are like the high-level domain names. So when your computer boots, it doesn't know its name, it just knows its address. It asks the network server, what's my name? And there's an authority, a network authority that tells it. So that's DNS, the domain name system, and it's hierarchical, and it's got a bureaucratic governance that's, open to a very limited number of people. So again, we've got this distributed open architecture of the internet, but it's only possible through hierarchy and bureaucracy. This is kind of your canonical model for understanding the different layers that make up the internet. So starting at the bottom, you've got your physical media that transmits, electrical signal. There's this link layer, which is how you send messages between two directly connected computers. The network layer, so packet switching, which deals with how to combine these multiple links into networks and networks of networks, so we can send the packets between distant computers. And a transport layer, which kind of is importantly coupled with this to increase reliability. So, if a packet's lost or the packets arrive in the wrong order, how do you manage that? And this is an application layer, which is how these programs make use of the network. There's heaps of different protocols, which I won't go through in detail. This would make up an entire textbook, and it does. I think I thought that I found this a useful way of visualizing it. The idea that if one philosopher in one location who speaks English wants to speak to another philosopher in another location who speaks French, and they need to translate it through the different protocol layers and then retranslate it, then they will attach these instructions to it, which are like the headers. But I don't know. I don't know if that helps. It helped me understand. Good question. That's not a silly question. Will there be an issue if delivered and received in different order? Yeah. Well, this is exactly what the protocols are for, so that you can increase reliability. And there are various ways to do that, you know, from keeping a constant connection open, a stream that you never shut off your connection with the one computer. So you send a computer and say, you send a packet and say, open the connection to me, that's acknowledged, and the connection is then open until you send the packet that says close the connection with me, and that's acknowledged. And then other mechanisms like, you know, you might have, and where's my beautiful GIF go? In the packet, this one says, I'm the first packet. This one says, I'm the second packet. And this says, I'm the third and last packet. And then the host can reassemble them at the other end. Yeah, so that's exactly what these protocols are trying to solve for. How do you transmit information in tiny packets in a way that they might get lost in the middle of the network, lost or destroyed, and then the person who receives them can still make sense of them. So up until this point, we're now at the 1990s. There are no browsers. There's no commercial use of the internet. Commercial use of the internet is forbidden by law. There's no way to link things. It's all based on messaging and email. But at this point, Apple kind of paved the way for personal computing. Here are a bunch of computers. So Apple brought in the graphical user interface and the mouse as a way of moving away from a computer that's just purely text-based. ARPANET became NSFNet, I think. NSFNet, yeah. So government legislation was passed, put these people in charge of opening up the internet. It eventually, in the mid-90s, went public. The internet was privatized, and a few ISPs took over, which is the internet that you're probably familiar with. I think I get onto that in a bit. But also, amusingly, the commercial internet meant you get ads for the internet, including this truly bizarre one. I think they're trying to say, hey, the internet's not just for nerds anymore. You can, you know, buy flights and things, perhaps. Not safe for now, yeah. Right. So in 1989, Tim Berners-Lee was working at CERN, and he came up with this document called Information Management, a Proposal. And his supervisor said, oh, vague, very vague, but exciting. So he recognized the potential. And it went on to become the World Wide Web. So the web and the internet are different things. And Berners-Lee is said to be the inventor of the World Wide Web, which is simply a document-based system for linking pages. So linking via hypertext. And this seems totally prosaic and quotidian to us, like not really revolutionary, but at the time, there wasn't really a way to navigate the internet. Well, there wasn't a way to navigate the internet. You know, there were other proposals. There was one called Gopher, which was like a directory where you had a centralized directory. It was at the University of Minnesota, and that way you could sort of go through and see all the pages that were on the web, which people say that failed because the University of Minnesota wanted to assert their intellectual property rights, which all of the internet pioneers were against. Just a moment. If you've also watched that documentary, you'll know that Ted Nelson was violently against the way that hyperlinks work here. He thinks it's very important that they go both ways, from source to citation and citation to source, and he came up with this idea of Xanadu space, which is this cool, like, three-dimensional linking. There's a clip, I won't play it, but you can come back and watch this yourself if you like. And he wrote 2 books about it, and he thought it was so important that text was linked in this way that he also linked his books. He kind of melded them together into one book. had this idea that everything is deeply intertwined. This is a catalog by Lialina, who's a net artist. The earliest websites were obviously academics, and they have this very distinctive style. And she's archived all of these websites, which are pretty amazing. When you get into making your own websites, you will find the joy of having these very straightforward styles. Yeah, as I said, the mid-90s, everything was handed over to ISPs. All the government control was handed over to private providers. And at this point, you know, the internet was, as they say, truly public. Public access meant that they were the first browsers. So if you have been alive a medium amount of time, you might remember Netscape Navigator, connecting and downloading things. This is going to take 39 years to download this smallish file. Personal computers, like in your lounge room. AOL Messenger. I think this is also not working, but it's the internet dial-up sound. You'll know what it sounds like if you know. Yeah, I feel like it's like the phone line kind of singing so that the internet knows. No, that's not important. Yeah, more Apple. I think the PC was actually more popular at the time, but Apple was clearly marketing to like a younger audience, and so that's what's prominent in my mind. And well, yeah, this led to the dot-com bubble. All of these new companies arose. So different, when talking about different ways of using the internet, you know, this is one that was resurgent and then died out, like peer-to-peer file sharing. A lot of these companies are now bust. As an early search engine. Yahoo obviously still going. Pets.com because pets can't drive. And so on. This was maybe the first social networking site, GeoCities. So it made it possible for anyone to make a website, but you know, websites really were like personal. They expressed your style. GeoCities shut down a couple of years ago. And again, this artist, Olia Lialina, kind of archived as many sites as possible. And if you can navigate through those sites, she's got them categorized in cool ways, like people who use the same image in different ways. I like this one, Divorced Dad's page. But yeah, when we think about personal computing now, it's different from this, you know, site that expresses you personally. Now it's a website that's generated for you personally. It's algorithmically generated, and everyone's feed is personalized for them. I've just got this here. This is the Internet Archive, which was started because this fellow Brewster Carl was sad that websites like GeoCities were going offline, and it's in this Christ Scientist Church, just like the logo. I thought was cool. It's a tour. Yeah. Will this work? No. Okay. It's quite beautiful, the inside of this church, with all of the servers that host the Internet Archive. I mean, obviously it's backed up in other places, but it's like all these flashing lights inside of this clean white columned building. Yeah, so after the internet burst, we come to the sort of companies that now hold a monopoly over the internet as we know it. Google, Facebook, maybe not MySpace, but Amazon. Amazon is in fact so ubiquitous that there was a journalist who tried to use the internet without using any of these big 5 companies and was completely unable to, just because so many sites use Amazon Web Services that it's basically impossible to not touch Amazon when you're on the internet. Things got much faster when broadband replaced dial-up, and when the iPhone launched, this drastically changed how we design, develop, and view the web. So when the people in the Plus cohort are developing your websites, you'll realize you start from developing for a phone before you develop for a page. So instead of these landscape sites that were common for desktop computers and laptops, you now move to a feeds model where, you know, you've got a reverse chronological feed and you scroll through, the impact of which I won't make a comment on, but, you know, it's definitely changed the way we interact with our devices. Yeah, this is a logarithmic scale, so you can see that processing power is increasing exponentially. And yeah, as I said, pages are now algorithmically generated for you. And that takes an incredible amount of processing power. And also now web pages go both ways, right? Like your browsing information is also collected by the company that you're browsing on. The environmental toll is massive, especially when you think now about artificial intelligence or machine learning, which takes even more processing power and uses even more energy, and is kind of considered totally necessary for everything online, or everything in general needs to be connected to AI. This is a very cool website called Low Tech Magazine. It's solar powered. It's got instructions for solar powering your own computer and your own local network, which are pretty easy to follow. When you visit this website, sometimes it's offline. It says, oh, we didn't have enough sun today, which is pretty cool. It's got when's the best time to visit, depending on how much sun that they're getting. There's an interview I've linked there with the designer who talks about yeah, the physical infrastructure of the internet. And I've just wrapped up that history with a picture of Edward Snowden, because I think that's like a key piece of internet history, right? Like in 2013, Edward Snowden said, hey, look at this information. The US national security agencies and the Australian government and governments, federal equivalents around the world have been spying on you through access provided through your phone companies, through these tech giants, and through tapping fiber optic cables. And they're getting through all the encryption. And everyone was like, oh, well, and continued using the internet just as they had beforehand. It's truly bizarre. But yeah, that's where we're at today. So that's kind of the history section. And I wanted to look a little at the building blocks of the web. So there are a lot of tools now online for building websites, but these are the fundamentals, and this is what you'll be looking at. The Plus program also hypertext markup language, CSS, cascading style sheets, and JavaScript. And I think of it as this kind of metaphor. What are the things? So HTML is kind of the structure of the things. It's the foundation of the house. The styling is how do the things look, the coloring, the font, the background colors, the images, where they're placed. And And JavaScript is kind of the functionality. Like if you have a button to click on, it turns the lights on. Like often a website now will have a dark mode that will be implemented using JavaScript in most cases. So there was a suggestion from Ollie that I might use developer mode on this site to sort of point out some of these things. So none of my JavaScript is working, which is why none of the videos have been playing. So we won't look at that. But usually you can right click on whatever browser you're using and click inspect. And this gives you your developer tools. So with all tools, it kind of influences the way that you use things, but you can use this little picker to kind of point to bits on the pages and say, what is this that I'm looking at? When you click on it, it says, that's an image. So here on the left is the HTML, the structure. You can say, this little tag is saying IMG, I'm an image. SRC, the source of this image is this website. I mean, sorry, is this link. And that's just a file that I've uploaded into a directory on my host server. This is your styles, your CSS, and you can see that I've set my images to have a max height and a max width. VH and VW are view height and view width, which is just, you know, a percentage of your browser. And that I've said that the body of my document, which is the main part, if I hover over body, you see it's kind of selecting the entire thing. I've said that I want the color of my text to be white. And that can be sort of, you can override that in different places. This you can ignore because it is something that makes your styling easier, and I'm sure you'll get to it. And another way you can look at that is to just view page source, which you've probably done before if you're anything like me and you like to steal bits of pieces off websites. But this is the entirety of the web page that you're looking at. So it's an HTML document, and I mean, I don't want to go into too much detail because you're going to be going over this stuff shortly, but you can see I've put my styles in here, and this is your CSS, which is your styling in between the two HTML style tags. I think that's pretty much everything I had to say. Are there any questions? If not, I'm totally happy for us all to eat dinner.
Feel free to like jump off mute if you've got a question, or if you want to pop a question in the chat, then we can have a look at the chat too.
I'll also
there's one question about if you prefer coding in a Windows or a Mac. Divisive question.
Yeah, I mean, obviously it's just what you're used to. It doesn't make a great deal of difference unless you're navigating around your computer using your terminal, which you will eventually do because it's just much quicker. And then there are different shortcuts, and you will prefer the shortcuts that you know, because otherwise you're going to be frantically Googling all the time, like, oh, how do I make a directory using Windows? I use Mac, and that's just an accident of history, but also it's good because a lot of real like hardcore computer nerds use Linux, and Mac is based on Linux. In fact, Mac stole the Linux core. So a lot of hardcore computer nerds hate Mac because they stole this open source thing and closed sourced it and made a lot of money out of it. But if you're Googling around the internet for commands, then nerds are going to tell you the Linux command. And that's great because you can use it on your Mac. Very partisan description of what's the difference between Mac and Windows. Yeah, other than that, I mean, you develop your own tools for coding, and people become very opinionated about it, but they're basically all the same. I mean, you can code in a notebook page and open that in a it's a website.
Totally. I usually say to people, go with whatever you're used to, or like whatever your work wants you to have. Is usually the best suggestions. Where can people have a look through your notes from today? Do you want to drop a
Yes.
link somewhere, or I can send something out afterwards? But I think there was some curiosity about some of the other links and videos that we didn't have time to or didn't work to capture today for
Sure.
people to explore.
I've just dropped the link in the chat, so it's just alisa.pizza/nature of the web, and nature of the web has spaces between each word.
Amazing. Cool. Well, we might hang out for we'll hang out for another couple of minutes if anyone else does have any questions. But thank you so much for that. That was like super cool to hear. There was a bunch of things, like I said, there was a bunch of things I didn't know. I learned a bunch of things too. So thanks for coming, everyone, and thanks for hosting us.
It was my pleasure. I had a lot of fun. I don't know if that was obvious.
I love it.
Thank you so much. That was great.
Glad you enjoyed it. Thank you.